Hello. So, hope everyone's doing good. I've done about half of the, maybe a little less, of the teachbacks, and they're phenomenal. It is so hard to be, express how proud I am of you, because in the end of the day, I work with a lot of people, and in my new role, there's a lot of geniuses. But over the last, let's say, 5 years, what you've done in this class is more complex, more impactful, and more difficult. And probably 90% of the people I've worked with have done that. It doesn't matter if they're data scientists, data engineers, data analysts, financial consultants, whatever their title is. The things that you've achieved in this class are quite amazing. So today I'm just going to talk about a couple different things, like Snowflake, paper by Microsoft, and Llama 3, just maybe like half an hour on that. And let's go over a real quick recap just to kind of remember what we've learned. So there's no real, I don't have a PowerPoint on this, I just typed some things out. I asked ChatGPT to do a couple things. So let's get into it. Let's do this. So there's a new paper. I'm not sure if I should start with this or what, but it is called Microsoft FastFlow 1. Okay, it's this. What's really interesting about this is this wasn't possible a year ago, 3 years ago. And, I know that I've kind of beat the horse dead, I guess. I don't really know the quite saying, about what the risk and rewards are. And here's a great example. This was just released just recently, last couple days. I guess same page. Yeah, so this is not less than a week. So basically what you do is you can take a static picture, just one picture of a person, and some audio, and it can do this. Okay? So this is what it says. Invest a framework for generating lifelike talking faces or virtual characters with appealing visual effects. So, okay, 512 by 512, 40 frames a second. And I think they did this on a 4090 on a single computer, so it's not like some supercomputer. It's just a 4090, which a lot of people have at home, and in 3 or 4 years, a lot more people are going to have them. And just a single picture and some audio.
So, sometimes nothing happens, and sometimes everything happens all at once, and you just
So very realistic.
Maybe you're in that place right now where you want to turn your life around, and somewhere.
So if you can kind of see, that's the image down at the bottom that they had the static, but look how realistic it looks.
Something was
The eyes aren't quite perfect, but it looks really great.
Trying to make.
The first thing we need to look.
Have you ever had? Maybe you're in that place.
The first thing we need to look at is the letter H, so the sound at the beginning.
My tip number 3 kind of contradicts my
You
tip
see
number
kind of the
4,
teeth sometimes have some
it's about challenging yourself.
artifacts.
Now on to the podcast that I recommend for older kids. The reason I recommend these for older kids is because
The bullet journal method is at heart a toolkit. The first question.
So remember, this is one image with audio input of 1 minute. Okay. So what is kind of neat is down here, some of these things. So you can control eye gaze.
I would say that these readers are not meant to look at him in any other way but with just...
There's a Mona Lisa one down here that's just ridiculous.
You stand up all the time. I'm a stand-up comedian, improviser by trade.
And remember these, so the original images, the pictures aren't from real people. They're from a GAN, like this person does not exist or this cat does not exist. Again, we talked a little bit about GANs. GANs, basically, we have two adversarial networks, and they try to compete to make the most realistic face. I think it's this person does not exist, there's cat does not exist, this house does not exist. And they're basically just GAN trainings. But here, you can also do things that are, with the Mona Lisa.
Yo, I'm a Rodsy. I don't play no Yahtzee. I go pop, 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 pop. My camera's up your crotch. See,
Yeah, I saw that on YouTube. That's what made me interested in this. So,
will prevent those cavities from getting worse and prevent new cavities. Just because you treat cavities, it doesn't mean they can't get cavities in any other tooth or around those other cavities.
So again, just looking at something simple like this, the pros and cons is now we can deliver, I guess, localized news to each household with a person that looks like them. I don't know if that's good or bad. There's pros and cons to that. We do very ultra segmented news, education, everything else like that. But we can also change crime videos. You know, you see a body cam video of a police officer. If we want to change the skin color of that person, boom, very easy. If we want to fake alter our news, very easy. I mean, this is literally one input photo, and some audio. Okay, we're not talking a ton of computer power. I mean, this is a 4090, so not a hefty video card, but not anything that's not consumer grade.
Say you don't want to see this person again.
You know, yeah, on desktop with a 4090.
I decided to focus all my attention, all my time.
So like I said, yeah, risk. They talk a little bit about risk and responsibility, but they talk about it at such a high overview. It's kind of, yeah. So it is very interesting.
So there could be some decisions that you have.
So if we think about this, I mean, so one picture and just some audio. And we learned last week we can make audio up. So very, very good things. I mean, I could do my whole lesson plans now, just, you know, send it throughout model and have it start doing the lesson plan so you never need to see me. I can phone it in completely. But I could also create customized content. Let's think about this. So I could create a video on a particular subject, very easy. And we know, we learned last week that the visual cortex back here is very large in humans, 50% of our cortex. So we're visual creatures. So we have the ability now to create ultra customized, ultra specific videos. But we also have the same ability, so it can be used for good or bad. You know, what's that saying? Electricity can be used to fry the man or cook the man's dinner. Same idea. So again, very new technology. This is why I'm trying to bring this to the forefront of you guys, because this is going to be your life, your choices when you move into business, what you want to do with this. Facebook, going back on to something else, released Llama 3, and I was downloading it just a second ago. Oh, there we go, so it downloaded. I played with it a little bit, haven't had a whole lot of time because they released, again, both these things happened within last week. Llama 3 is a very powerful open source model. The weights are open source. It's very impactful. Where ChatGPT is closed source, we might have a hard time kind of change it. OpenAI's Facebook's Llama 3 is open source, at least the weights are. Which I guess everything. Yeah, the training data set is 7 times larger than Llama 2, including 4 times more code. It was trained on, I guess, a 24,000 GPU cluster. So they go into a little bit of it, and like I said, it's can you explain? Let me. Oops, sorry, you guys here. So sorry about that. Can you explain GANs by Ivan Goodfellow? Why are they important in computer and machine learning? Yeah, I guess that's fine. You see that when I've used it before on my other machine, it's relatively fast. So again, this model sits on my local machine, so it's not hitting the internet. It's you know, it's my own model. No, it's not my own model, but again, it sits locally on my machine. What is a blue moon? Yeah, I guess a blue moon's like when they have a moon twice in 1 month, right? So, is the rare lunar event will appear to be blue instead of yellow? So I thought it was when they appear twice a month. I guess not. So again, very, very cool. Let me go back since you guys probably didn't see this. Here's Llama. Just go to llama.meta.com or just Google Llama 3. It's a really powerful model. So far, like I said, I have it on another machine I use more often, and it's nice. It's good. I mean, I haven't set it up in code, or I haven't really done a whole lot with it besides ask it just dumb questions, or I asked it how to convert some code down to Markdown because I couldn't figure that out. I asked it. 3 or 4 people wrote about federated machine learning. And I understand the idea of federated learning, but I've never really done federated learning, so I was going to do maybe a demo of federated learning. But so like I said, it is really neat. So I'd recommend you guys play with it. You know, again, if you have Ollama, just Ollama and then run Llama 3. Super great little model, really neat. Let me close this out here. Okay, so let's see what else was on. So now, not really, kind of a review, but not really a review. So I want to talk about Snowflake. Okay, so kind of going on to Snowflake because this kind of gives me the first 4 or 5 lectures to kind of encapsulate. So in the world of databases, remember these are kind of generalized, I guess would be the best word to explain it. So what one person's data lake is another person's database. So yeah, okay, so I don't have a really good table. I have another one and the other. Actually, let me pull up a good table of the difference. Okay, this is kind of one way to think about it, but I want to kind of change this around here a little bit. So what happens is you have a lot of different systems collecting data, okay? Thousands of different billing systems, CMRs, different, in my case, EMRs, different claim information, different call centers. I mean, if you just, you look at, I don't know, McDonald's or anywhere, you have all the suppliers, you have all the employee databases, you have all the sales databases, you have all the building maintenance databases, you have thousands of different databases. It's almost too hard to kind of wrangle them all and do something with them. So what we kind of do is we kind of compact and say, hey, I'm going to pair this one up with this story, with this, and kind of transform it into a data mart. Okay, a data mart, the idea of a data mart is just basically it's kind of one source of good information for reporting. Let's see, do I have another video of it here? I thought I did. Okay, so this kind of gives you the idea. So you have all these different data sources, and then somehow you kind of merge them together, or just parts of them, to get a better, cleaner data. They move them to a data mart. Okay, and the idea of a data mart is that people say that it is, you can use it for reporting, you can use it for analytics, but at the end of the day, a data mart is really a place where you have intelligence or actionable data. Okay, now one of the problems is that with a data mart is that sorry, itches. I think it's allergy season. Is that sometimes it doesn't always have enough data, or it's not big enough. So there's something called a data lake. Okay, and a data lake is more a collection of like all your data, and a lot of times you use it for machine learning. So a data mart's kind of more focused, or more regional, or more specific. A data lake just has more data. Here's like, you can kind of see it here. So data warehouse, so you kind of like put it together and you kind of make it smart and you kind of get reports out of it. That makes sense. In data lake, you just kind of throw everything in it. So a little less structured or semi-structured, unstructured. They call it data swamp. But so there's this kind of point where, hey, how do you go from here to here? Because a data mart is nice and organized and clean, and at least has some type of focus, but doesn't have all that information sometimes you need, especially nowadays with machine learning and being able to hack big data. Or like I told you, 80% of the world's data is unstructured. So you want access to that. That's 80% of your data you're not using, or at least semi-structured, we'll say either one. Versus the structured data, so you want access to it. So how do you pair everything together? Well, that's where kind of Snowflake came in. Snowflake came up with, what's the term they use? Data lake? Data mart? Let me Google it real quick. They came up with some crazy term. I can never remember it. Data warehousing. Yeah, they have some term for like data lake or data house or something else like that. So I kind of just want to give you, this is done by ChatGPT, but I just want to give you an overview. Hey, why are people using Snowflake versus using Amazon RDS, which is something I'm very familiar with, or Aurora, a lot of other programs out there, or Google Cloud, or Azure SQL, which I've never used, but Google Cloud and Amazon I'm very familiar with. And at the end of the day, it's just Snowflake is designed for business, and RDS, not that it's not designed for business, but it's not designed the same way, and it's kind of hard to explain. So one of the big problems, once you get bigger and bigger and bigger and more companies, or more departments, is that data gets siloed, and that's a really, really big problem. So if you own 2 or 3 McDonald's, you think the data would be shared easily between them. That's just not the case. Maybe one McDonald's has one particular ordering system, and another McDonald's, even that you own both of them, have a completely different ordering system. So you don't know if one store has this type of inventory and the other one doesn't. It's impossible to figure out. And this just gets more and more problematic. Once you have analysts, once you start having teams, that data kind of gets siloed by that team. What do I mean by that? I mean that, hey, you might have, in the NFL, I don't know what I thought, maybe I was looking at somebody's paper, but NFL, you might have a marketing analytics department, and they keep their data. You might have a recruitment analytics department, and they keep their data. And you might have an owners, or like, I don't know, yeah, I guess owners analytics, and they might keep their data. And then you might have player performance analytics, and you might have that data siloed. And you might have like I don't know, location or whatever they play in the Super Bowl, like stadium analytics or stadium performance. So now you have, I don't know, 6 or 7 different siloed data sets. So if you want to pair up the owners analytics versus the stadium analytics, you can't. Or if you did, you have to contact somebody and write. It's just a nightmare. Okay, and so that's what RDS and a lot of these other things a lot of times often are. They'll run a database per department, per person, per team, and sometimes it's not always easiest to kind of get that data across teams. Snowflake has really kind of changed that. They make it, they really focus on enabling a business to kind of share the data appropriately with right security. Yeah, I guess that's the best way to say it. Now here's another really neat thing. So storage compute separation. This is really interesting too. So what do we mean by this? What is SQL? SQL is a language where we store data. So we have data, and we need to be able to store data and pull data. Okay, so at the end of the day, SQL is not really a compute language. It's not designed to be a compute language. It's not designed to be a language like that. It's meant to be a structured query language. It's meant to pull the data for us. Well, if I'm using an MS SQL database, I can do sums, I can do averages, and they get more and more complicated. Okay, but that often uses a compute on the SQL server. So my work will go through and buy a big, I don't know, $100,000 Dell or HP server. It will load a database on that server. So now you have a physical server like you see on the network shows or anything else like that. You have like a 4U or 2U network server, and when I run queries, other people run queries, it runs on that CPU. Well, good and bad. I mean, good because it's running over there. Bad because more people access it, the slower that compute goes. Also, it's not scalable. If I have a really, really big or really, really complex query, I can't scale beyond, more or less. There's ways to do it in Microsoft, but you can't really scale beyond those cores. So Snowflake is kind of really decoupled the true SQL and the compute. So you need compute somewhere, Databricks or even Snowflake has some of it. But yeah, so it's a really neat idea. We're not really using compute now. Like things like Aurora kind of have scalable and growable compute, and other things have scalable computes, but they're not separated per se. And if you think about it, we're doing this. Sorry, machine. So this is just like a little SSD drive, okay? There's no real compute on here. So this is just pure hard drive. So I can plug this into my Mac. I plug it into my PC. I can take this and put it on a supercomputer. So this is completely separated from any compute. Now my phone, where my phone is, okay, my little old lucky dog, this is not. This has storage and compute in one. So now if I'm trying to do something really heavy machine learning on here, I can't. At least not very easily. I mean, this has a little, like, I don't know, maybe metal processor or some type of CPU or GPU processor, but I can't really I can't do these really crazy things on here. So if I have really good data on here, what do I have to do? I have to offload it somewhere else. I have to compute it somewhere else and maybe load it back on here. It's not the most efficient system, okay? So that is why that scalability in terms of compute and storage are completely independent is very, very important. Now, another thing that's very interesting too, and I've never really thought about this. I've thought about it, I just never really realized how important this is. So if you use AWS, you're an AWS house. Basically all your services are AWS. For example, UNLV is a Google house. We use Gmail, and we use Google Drive. Everything we kind of do is in Google Cloud. Well, Snowflake, you can get it on AWS, so you can use AWS storage, compute, everything else like that, or you can use Azure, or you can use Google. So it is not dependent on any one service. So which is very, very good, because some businesses use multiple kind of houses or multiple cloud services all at one time. And why do they do that? Well, because one program is designed to use AWS, and 3 other programs are designed to use Azure. Okay, UNLV. So let's say we're a Google house. We have Gmail. We have Google Drive. We have all this stuff. But for some reason, I need to use Hugging Face, or I need to use Google Compute Platform, something else like this. I have to create an account, create APIs and keys, and share everything back and forth. Not very easy. Snowflake makes it very easy, because Snowflake does a lot of that integration for you. Okay. So yeah, also too, in terms of performance, so there's a lot of videos on what makes Snowflake fast. And a lot of it's SSDs and per second billing and things like this. So if we remember, let me see if I can pull it up here. Yeah, here we go. We kind of remember this, okay? How complete is data? How timely is data? Do we have good data coming in? Also, you remember the 10 V's of veracity, variety, the type of data we coming in. So when you really start thinking about this, it is, do I have one in here? I do not. I don't. But you remember that, like, the 6 V's of data? It might have been week 3. Basically, how varied is your data? What does your data look like? How often is it coming in? Well, in the past, typically you'd kind of design your database based on those factors. So, hey, you have a large chunk of binary data. You have a lot of blobs coming in, okay? You design one type of database that way, okay? Blob pictures, blobs, binary objects. You have a database that has a lot of small reading. You design it another way. You have a database that's designed for a lot of writing. You kind of tune it for another system. We think of cars the same way. I have a Ferrari. Ferraris are meant to go fast on nice smooth roads. It's not a very good idea to take a Ferrari off-roading. We have a truck. Trucks aren't really good at gas mileage, so they're not maybe good on smooth roads, but they're good at off-roading. Every vehicle kind of like that's tuned for performance. Well, Snowflake's kind of designed themselves to be a big data, big compute, big storage type systems. And maybe at the time when they did it, it wasn't necessarily the best idea. But as big data just kind of exploded, they were just situated right. A couple other things here that I put in here. Okay, so again, multi-cloud compatibility. Okay, so you can use it against AWS, Azure, Google Cloud Platform. this multi-cloud strategy mitigates risk. So that's good. And also too, if you're a Microsoft house, it's easier to integrate Snowflake. If you're an AWS house, it's easier to integrate Snowflake. So again, they've made it very easy to use their SQL system and their storage system for data compared to everyone else. Another thing too, so in databases, sometimes we make these temp tables. And a temp table is just like, so maybe I have a table that has 100 columns and 1,000,000 rows. But I don't need 100 columns. Maybe I only need the first 6 columns, or I need some type of derivative information. Okay, let me give you an example. Maybe the president of UNLV doesn't care about how you did on each assignment. Maybe he only cares about how you did overall in the whole class. Maybe he wants to know, hey, what was every student's grade throughout the whole university of just the final and the midterm? Okay, so he can get rid of all the other grades and just pull the students, INSEE, the student's midterm grade and the student's final grade. And that thins down that data. So instead of pulling 30,000 students with maybe, millions of different grades and assignments, everything else like that, midterm, final, INSEE. 3 columns, 30,000 rows. Very, very clean data. So to copy that, though, in traditional databases, you can either create a temp table, you can create a working table, you can do subqueries. There's a couple different ways to do it. However, with Snowflake, you can clone that data very easily with basically no cost. And you download those costs, but it makes working on your own set of data, or makes kind of data cleaning very, very quick and very efficient. Now, another thing too that I don't think gets enough credit. So we know that in Hugging Face, let's see, go here, close this out. Hugging Face. There we go. Spaces. So when you guys, we haven't really created spaces. We've kind of played around with them, okay? But one of the big problems is, how do we take this data, sitting in a database, and present it to non-technical people? In business intelligence, we use either Power BI or Tableau. You can use Excel. There's a bunch of different ways to do it. Would I pick one that's not? Find one that's funny. There we go. Okay, so this, man, it is not my day. There we go. So this is Grotto. But okay, Streamlit is basically a way to take data, or Python and data, and kind of make a web interface very easily. Now there's more complex systems, to Django, but at the end of the day, if you just have some very basic data and you just want to share it with somebody, sometimes it can be kind of hard. I mean, you can export it in email, but that's not really the way the world is. So let's say I have I want to have a report of when everyone comes in the front door. Okay, so I have some type of card reader system, and every time I get to work, I scan my card reader and I go in the door. I leave, I scan out. Okay, no big deal. The airport has it, a lot of businesses have it. So now my boss says, hey, can you create a dashboard to see who scanned in at what time? I'm like, okay, so now I have to pull up the Tableau. It means I have to have Tableau, and we have to have a Tableau server, or it just becomes super complex. However, Streamlit, or let's see if I actually click on this, Grado, you can do basically that very easily. Literally drag and drop. You have your data, you put a couple things in there, and boom, make Streamlit apps super easy. Actually, and they have a great documentation system. Streamlit.io, is that what it is? Oh, what do you know? I got that right. So Streamlit is just, like I said, a way to kind of share data apps. They're called data apps, or so they're not really full apps, but they're very easy ways to make take your data and present it to non-SQL people. Now Snowflake bought Streamlit a couple years ago. Don't ask me when. 2 years ago, 3 years ago, and they haven't really fully integrated it yet. But I think Streamlit and Snowflake will be very, very powerful once Snowflake kind of figures out how to really use Streamlit. and how to say, hey, here's your data. We're going to allow you to make your own kind of data app, and here's how you do it. It's very easy. And they're working on it. I think it's in public beta, but I think it's going to be super powerful. So with with Snowflake, again, it's kind of the merger between a data lake, and let me show you why, and a Lakehouse. So we're taught this is how data engineering looks. Oh, it looks so nice and easy. Okay, we have data at rest. Okay, we have some databases. We have made flat files. We have Tableau. We have these nice data lakes. We have cloud services like Snowflake. We have apps that use all this stuff. Oh, nice, easy. Promise, this is how it looks in the real world. Then this is probably underselling it. Okay, so you have a product, and it pulls from a flat file. It pulls from Snowflake. It maybe pulls from real-time imaging. It pulls from cloud data. I think this is for some, because it says claims. So your claims data pulls from a database of claims. It pulls from a database of insurance. It pulls from a cloud data storage, because the doctor's office is often in a cloud. It pulls from a data lake, because that would be maybe like a list of all the procedures and ICD-10. I mean, it gets really messy. So Snowflake kind of hopes to eliminate a lot of this. Hopes to have databases integrated with a data lake, so it kind of gets rid of these two. Also with a data stores. So there's 3 of them. It tries to merge all into one. And to the data mart, so 4, it tries to get rid of all this stuff. And then with them buying Streamlit, they're trying to do little apps like this. Okay. So I think Streamlit's going to be a lot bigger than I think a lot of people give credit for, but I think it's going to be a big game changer. I talked a little, when we look at compute, I did want to talk a little bit about compute, because for compute, so you get the data, now you have to do something with it. You have to search, you have to do some machine learning, you have to do regression on it. Where do you do that at? And that can be difficult. So let's say you want to do some type of complex, not even complex, you just want to do some math, but you have 500 million rows, and you got to pull all these different records. It can be computationally expensive. Databricks is one of the other programs, a website, platform, that can take Snowflake data or other data at the end of the day, kind of turn it into a Jupyter notebook, and then run it through Spark. Now, none of that, I don't want to say none of that really matters, it's really cool, but at the end of the day, what Databricks is compared to other services is that Databricks is kind of like an advanced Jupyter notebook with some machine learning capabilities, both integrated and external on it, and it's really designed to not run on a single core, single Jupyter notebook instance. Okay, it's really designed to auto scale up on big, huge clusters and really process data almost transparently, so you don't have to worry about writing a bunch of Spark code or PySpark. Kind of some ways, but not really. And two, they've really hit the machine learning aspect very hard. There's a model, DPMS. It's a large language model, Databricks, DRMS. What it is? It's just LLM. There we go. Yeah, DPRX. There we go. So this model is a new model, and it's phenomenal. So they integrate this. So they integrate their own LLM into Databricks. So now you have a Jupyter notebook, more advanced Jupyter notebook, but basically a Jupyter notebook, which now you can run every cell individually. When you get to something that's really computationally complex, it goes through a Spark cluster, goes and it clusters that data. So now instead of having one SQL pull, one data pull, you have multiple machines or multiple clusters pulling that. And now you can do your own LLM without having a lot of problems. Okay, so very, very, very cool. So those are kind of the two things that people kind of wanted to know a little bit more about, and I kind of wanted to talk on. Where are we at? We're at 34 minutes. So that was pretty much the basics of this stuff. A lot of that was big data, the different types of data, different sizes, reading and writing. You understand basically the basics of NLP. I'm trying to think if I want to pull up some of the PDFs. So I think I got most of it. So remember the text vectorization and classification. Okay, that is when we take. Okay, so why do we vectorize data, words or anything else? We do that so we can run it through a machine learning model. So in our brain, how do we perceive the world around us? We do it through electrical stimulation, through little neuron firing, through electricity, through the chemical messenger system. Well, how does a machine learning model understand 12? How does it understand red? Well, what we have to do is kind of take those words and turn them into some type of math formula, or we're using math, we have to turn them into a line, a number, something so that a machine learning model can say, hey, these two numbers represent something very similar because they're close to each other, or they represent something very different. That's the basic process of vectorization. I'm trying to think how much more detail I want to go into, and I think that's good enough for most of this class. There's all different types of vectorization. Remember related terms like LDA, chunking, TF, IDF, which is document or word document frequency. It's how sometimes a valuable word like Apple or John or something, since it may appear less in a document, it might be more important. Okay, so that's TF, IDF, things like that. Let's see. Now we went into BERT topic and different models. Remember, BERT and BERT topic are just one type of topic modeling. Now, granted, the nice thing about BERT topic, one of the reasons I chose to teach a little about BERT topic, is it does a lot of rudimentary steps. It does dimensional reduction. So if you have this big chunk of data, you need to kind of get rid of things that don't add value and kind of get it down to something that adds value. So BERT topic does a lot of those things. You can see it when you run BERT topic. It shows you kind of what it does. And that's why I think topic modeling with BERT topic is easy and very valuable, very, very valuable. We did a lot of projects, which is good. You guys just kill it all. And then future direction. I tried to get Google Copilot on my machine, but my machine just will not install Google Copilot. But you're starting to see Databricks has an AI assistant in it. Windows has an AI assistant in it. I know Alteryx is, I think, trying to build one in. I think Tableau is trying to build one in. A lot of programs are trying to build in some type of PDF. Acrobat PDF has Copilot has some type of AI intelligence built in. So a lot of these programs are really trying to build in large language models or machine learning. Why? Because again, it makes life easier, and it moves from the deterministic search to a more creative, more intelligent search. But they're both pros and cons to this. Okay. We talked a little bit about ethics, actually a lot about ethics. So let me look at a couple of the PowerPoints real quick and see if there's anything else we need to cover. I mean, you can see right up here, AI assistant. Give me a second to process. So, what is the purpose of descriptive analytics? So now it's looking into this document and finding that, and boom. So you're seeing a lot more of these AI assistants being built into every application. I think you're going to see it more in your phone, more in your earbuds, more in your car, and a lot more of everyday life. Okay. Imagine going to a restaurant and having some type of LLM, so you don't have to wait for the waiter to ask them a question about something. Hey, is this gluten-free, or can you change this? Oh, here's the big views of data. Okay. What else we have? Let's skip ahead a little bit. We talked about vectorizers. So vectorizers or tokenizers, either one. You have to use the same one more or less to basically pit. If you encode everything in one method, you have to use the same method to add more data, to unencode more data. So if I'm writing a book and I'm writing it all in English and then I want to add another chapter, it has to be in English. Bag of words, what else? So transformers, we did spend a lot of time in Hugging Face, and we did use the transformers library. I hope you use the transformers. I hope you use some of the different tools that they provide. I also hope you use pipelines. Pipelines is a really high level way to use models in Colab or in transformers. Pipelines just kind of like this 10,000 foot overview of, hey, how do we play with this model before we really dig in? That's the way I kind of see it. We talked about vector databases. We didn't set up a vector database. You know, you're not going to be data engineers in terms of, hey, you know, let's, you know, we need to install a vector database, blah, blah, blah. You know, if I had to play with a vector database and I was a student, I would find, you know, some online service I could use it for free and play with it for free online, and kind of learn it that way. I know at work I've seen people set up a little vector database on their machine locally, like I think it's like NoSQL or SQLite is an SQL one that you run locally all the time for deving. Well, they make vector databases the same basic idea. So let's see what else. We talked a little bit about fine-tuning RAG, not in this lecture, but fine-tuning RAG and LoRa's in terms of how you take a large language model, a model, you know, that Llama 3, it was trained on like 15 trillion tokens or something outrageous. I mean, it's an 80, the big one's like, I think 80 billion weights. So, I mean, it's quite amazing, the size and the amount of work it takes to actually generate these. So it's not practical that most companies or most people can actually really create them or tune them or anything else like that. So fine-tuning is the idea that, hey, we have this model and we just want to perturb the center of it, the weight, okay? LoRa is basically, we're going to kind of freeze it for a second and we're going to kind of add something to the end of it to perturb its output, to make its output look more like what we want, either in the large language model where we tell it, hey, kind of this is the language or this is the terminology or this is the technology we use, or a RAG, RAG, where you kind of feed it a vector kind of in you chunk your data and then create a vector, and then you feed it more syntax in the beginning. Yeah, that works. So there's those. Let's see, prompt engineering. So prompt engineering, we covered that a little bit. So the idea is that humans, we've evolved to kind of understand what you want when you ask for a question, except for, I guess, me and other people. In certain diseases, can't always understand people. Machines aren't that way. You have to be very direct with them and ask them very specifically what they want or what you want them to do, because machines can't infer very well yet. So just keep that clear. There's some tips on prompt engineering. There's classes on prompt engineering. It's not a bad thing to learn how to write better prompts. It's something I'm always trying to achieve, to write better prompts. Let's see what else we have here. This was a recent one. We talked about the value of the teachback. So the teachback is an ability to communicate a technical idea to your peers. So it's super important. Let's see, we talked a little bit about GANs. We talked a little bit about Ollama. I really recommend you guys look at Ollama. Let's see what else we have. Image and videos. You know, I'm a big image and video person. I think it's going to be very impactful. We talked about Hugging Space. So Hugging Space is kind of broken up to like data sets, and at least in basic spaces. Yeah, I mean, you kind of played with it. Yeah, so where's pipeline? So here's pipelines. So pipelines are, hey, do I have a sample code? I think I gave you some sample code in Colab. Yeah, right here. Load this really quick. I don't know if it's on this account or my other account. Yeah, I think I took it down here. Yeah. So a pipeline is basically a very high-level way to kind of test something. So you say, hey, here's a corpus of text, here's a chunk of text, and I just want to take a pipeline and encode it. I want to take a pipeline and pull a sentiment analysis. I just want to play with it a little bit. Remember, I recommended or encourage you guys to use your homework and post on LinkedIn or other places. So I think that was a major points of some of these things. I'll post these PDFs on one class, on one section. I will also post a couple, oh yeah, regex. Talked about regex. We also talked about data cleaning a little bit, engrams, things like this. But I will post this. I'll post a couple machine learning just lectures in module 15. What it is? I think we're week 15. And then let me know if you have any questions. Next week, there's not an official lecture, but I might just cover something. It's completely optional if you want to watch it or not. Next week is study week. Again, I'm not real big on giving you a midterm in terms of didactic, hey, material like this. So the midterm might be write something. The midterm might be just 20 easy questions. I'm not sure. We'll figure it out. I'm open to suggestions. Feel free to email me. I might give you a small data set and have you pull words out of it using Hugging Face pipeline. Everyone in this class can handle it. My job's not to failure. My job is to get you to the goal and to get you to succeed, to have you have a deeper understanding of how to use LLMs to tackle a problem. Okay. Otherwise, have a great week. Let me know if you have any questions. Hopefully the teach back will be great in the next day or two. Thank you.